Hi and welcome back to the last module of our CS165 course. In this video, we will discuss about query processing and optimization. So, at the end of this module, you will be able to understand how the DBMS processes your SQL queries to obtain results using this four-step process. You will also know how query optimization is done, and we will show some heuristics or rules that works in most cases but is not guaranteed to be optimal in every case for query optimization. And we will show how query trees are converted to query execution plans. We will also discuss about the different algorithms for our SQL operations such as select, join, project, and of course set operations like Cartesian product, etc. And then we will discuss about cost components. So in query optimization, we minimized some cost. So we will present some different cost components or cost metrics here. And then lastly, we will give some input parameters that directly affects the complexity of a query. So you will know how certain operations or specific queries are much more slower compared to others. Okay, so let's start with this image. This image basically describes how the DBMS process a query. It describes how a query written in a high-level language such as SQL is converted to the result of the query. So it starts with scanning, parsing, and validating. The result of this process is an intermediate form of a query in tree or graph-like. It's called query tree or query graph. Depends on the form of the query. And then it is followed by query optimization, which then produces an execution plan that goes through the query code generator, which then produces a code that will run on a database processor to produce the result of the query. Okay, so let's go to the specifics. So given an SQL code, scanning identifies the language tokens such as keywords, attributes, names, or relation names, of course. So for the keywords, we have the select, from where, and then for the attribute names, we have the P name, P number, etc. For the relation names, we know that employee works on project or tables. So the next step is then called the parsing. So parsing checks the syntax, and then validating makes sure that the tokens identified through parsing and the syntax actually makes sense in terms of the validity of the operations. Okay, so the result of the first step is an intermediate form of a query called the query tree. Okay, so the query tree is just a relational algebra expression that is equivalent to the SQL code. And in the tree, the leaf nodes are the relations or the tables, and the internal nodes are the operation. Okay, so in this example, we have here the employee works on project as the leaf, and we have the Cartesian product as the internal nodes, as well as the select operation and then the project operation. Okay? So, paano na i-evaluate yung isang query tree? Internal nodes are executed whenever its operands are available. So, for example, hindi pa natin pwedeng ma-evaluate yung operation na to because sa bottom part, hindi pa na-evaluate yung resulting relation of the Cartesian product. Okay, so it starts with this evaluation, and then the resulting table will then be replaced. Itong buong subtree na to after executing the operation. Okay? And then, finally, kapag available na yung employee cross works on, then we can perform another Cartesian product on the resulting table and the project table. And then, later on, the execution will be terminated kapag nakaabot na tayo sa root node. Okay, so that's how a query tree is evaluated. Given a query tree, the query optimizer produces an execution plan. Given a single SQL query, there are many ways how to retrieve the result. So, maraming different possible sequence of operations that produces the same result. So, the goal of the query optimizer is to choose an optimal one, ideally. But since getting the optimal strategy is time-consuming, the result of the query optimizer only promises optimality for simple queries or reasonably efficient for most queries. Okay, so here's the general idea for query optimization. The first step produces an initial query tree. So yung scanning, parsing, and validation, it creates an initial query tree. It will then have a series of transformations. So that version of the query tree will be modified and transformed to get an equivalent query tree na mas mabilis mag-run kapag ka in-evaluate. So, the way how the query optimizer performs is by applying some heuristic rules. So, one example of a heuristic rule is this. So, before performing a join operation, you need to perform select and project muna. Why? Because we know that join operation is a multiplicative function. So, if we have two tables na malaki yung size or the number of records, like for example, one table has n, another table has m tuples. If you wanted to do a join operation, meron tayo ng n times m naively. If we have, let's say, a large values for n and m, medyo matagal yung n times m. So, by performing select and project, we are minimizing the total number of records using the select, and we are also minimizing the total number of columns. So, essentially, before you do the join operation, mas maliit na lang yung parang input tables for the join. So, that's just one example of a heuristic rule. In fact, marami pang iba. Okay, so from our reference, actually, merong binigay na steps in converting an initial query tree during heuristic optimization to get something better. Okay, so this equivalent query tree has the same result dito sa nauna. Okay. The first step is obtaining an initial query tree from the SQL query. If we follow the evaluation of this query tree, the tree will actually create a very large file from the Cartesian product of employee works on, and then later on, the Cartesian product of the resulting table and the Cartesian product of project. Okay, so after nun, saka pa lang tayo magpa-perform ng select operation. But actually, we only need one record from this project table, and that is the project with pname equal to Aquarius, and we only need some few records of the employees that were born in 1958 and later. So, medyo inefficient talaga itong tree na to. Luckily, we can improve it in the next step. Okay, so in the next step, we move the select operation around the query tree. Motivation dito is that we wanted as much as possible na filtered na yung mga tables natin from the bottom parts of the tree. So, if we apply the select operation, ang i-return na lang ng operation na to ay some subset of employees na pinanganak 1958 and later, and then just one record with pname na Aquarius. Okay? And then, we can also do yung select operation for the resulting Cartesian product of these two tables. Okay, so mas maliit na yung mga records na umaakyat sa query tree natin if we do step 2. Okay, next is applying the more restrictive select operation first. some select conditions are much more restrictive than others. Yung ibang condition, we only expect one record. Other condition, we expect multiple records. Okay? So, as much as possible, yung idea ng step 3 is to move the more restrictive below the tree so that you can filter the tables as early as possible at hindi na dumaan pa sa mas maraming operation. Okay, so in this case, so instead of having yung operation na select birth date para sa employee, yung sub 3 na to ay nag-swap sa part na to. Okay? And since pwede namang pagbalik na rin ng Cartesian product, this is a valid transformation. Okay, so yung mas less restrictive, iaakyat natin sa 3. Yung mas restrictive, ibababa natin sa 3. Okay, so why? Because as much as possible, ayaw natin umakyat yung mga necessary records sa 3. Kasi as you go along the 3 sa evaluation process, mas mababa yung part nung operation na yon, mas marami siyang dadaanan hanggang makarating sa root node. Okay, so that's for the step 3. Step 4 is replacing the Cartesian product and select with the join operation. Okay, so we know from the previous modules that yung Cartesian product then select is equivalent to the join operation. However, yung Cartesian product and then select is the naive version of the join operation. So, ayaw natin na gamitin yung Cartesian product then select, but instead, we will use the join operation because there are a lot of other optimal algorithms for the join operation na madidiscuss natin later, na hindi kasing naive ng Cartesian product. Okay? And then, filter the result of the Cartesian product. So, yung Cartesian product natin dito, napalitan na natin ng join with the conditions na ginamit for the selection. Okay, so we have this as the condition for the join, and then we have this as the condition for the join. Okay, so the last step will be moving the project operation down the query tree. So, kanina, we are trying to minimize the number of records, but here, we are now trying to minimize the total number of columns. Kasi, as much as possible, hindi natin gagamitin or hindi natin ipapaakyat sa query evaluation yung mga columns na hindi naman necessary. Okay, so that's for our step 5, and now we obtained a query tree that is equivalent dun sa nauna but much more light in terms of computation. So that's the application of several heuristics in query optimization. Okay? So, ang nabanggit dito sa part na to is that after query optimization, we have an execution plan. Now, the question is, now that we have an optimized query tree, how can we get the execution plan? So, ito yung sinasagot ng next slide natin. So, to convert query tree to an execution plan, the query optimizer chooses an algorithm to execute each operation or each access method to files. So, for example, we know that for the query tree, meron tayong select operation, meron tayong join operation. What we'll do in the execution plan is to identify yung mga different algorithms to use for each operation. So, there are other algorithms for doing the select. But for example, yung laman ng execution plan is use the index search for select, and then use the table scan as access method to employee, and then use the nested loop join for the join operation. So yung execution plan is a mapping of specific algorithms to the operation, and then yung code will just do the execution plan according to the evaluation of the query tree using the algorithms specified. And then next is, we need to specify the evaluation, okay, of the query. There are two types, the materialized evaluation and the pipeline evaluation. The materialized evaluation is we create temporary relation every time there is an operation, and that temporary relation is the input to the next operation. For the pipeline evaluation naman, hindi tayo nag-create ng temporary relation, but the resulting tuples, pwede siya makakreate ng table, but hindi siya sinesave as another table. Yung resulting tuples na yan will be forwarded directly to the next operation. So, parang may buffer lang to store the results. So, that's the pipeline evaluation. The next few slides will be about the different algorithms used to implement the SQL operations. Let's start with the select operation. Well, select can be reduced to the problem of search because given a set of records in a table, we search for a subset of those records that satisfy a certain condition. And in this video, we will only discuss 6 algorithms for the select operation, pero marami pang iba. Okay, so let's start with the naive algorithm, which is linear search. Basically, for linear search, we check every record and test whether the attribute, yung mga hindi nag-satisfy sa condition, yun yung mga mafi-filter. Okay, and then for the second algorithm for search, of course, we have the binary search. But for binary search, it is required that the data in the attributes kung saan may certain condition tayo ay ordered or comparable. The advantage of binary search is mas mabilis, of course, yung access. It could be something like login. But, of course, if we use data that is static and most of the time access lang yung need natin, then binary search is okay. But for a very dynamic data, hindi maganda yung binary search because we always need to pre-sort the data. Okay. And then we have the third algorithm here. So the difference of S1, S2, and S3 is that walang additional access structure like an index or hash table in accessing the records in the table. But for S3, gumagamit siya ng either primary index or a hash key. So index or a hash. So for S3, it is required to have a condition that is equality and involving yung key na attribute, which is the primary key. So if naka-index yung primary key, then we can use the S3 algorithm for search. Same is true kapag ang access structure natin is a hash table. Okay, so ang isa pang caveat for S3 is that ang nire-return lang ng algorithm nito is just one record at most kasi pwedeng 0 kapag hindi nag-exist yung record na yun. Okay, so this algorithm is applicable if you wanted to search for a student with a specific student number or employee number kapag employee gusto natin ma-search. Because we can use the student number or employee number as the primary key. These 3 remaining algorithms can retrieve multiple records and can evaluate conditions such as inequalities or range conditions, unlike yung naunang tatlong algorithms natin. S4 is equivalent to S3, which uses primary index to retrieve multiple records, so hindi na lang single record. S5 uses clustering index to retrieve multiple records. Yung clustering index, it's applied to non-key attributes, so hindi kailangan primary key. Clustering index can provide a fast way to retrieve records with the same value. So, ang ine-evaluate lang natin dito is the equality condition because it can provide us a faster way to retrieve records that has the same value for a particular attribute because they are physically stored together using the clustering index. So, yung S6 naman uses a data structure called the B plus 3 to efficiently access the contents. So, it works for both equality and inequality. So, it can produce a single record if it's a key attribute, or it can produce multiple records if the attributes are non-key. So for B plus 3s, aside from allowing faster access of contents, it has also an efficient way of inserting the new data or deleting the data. So it works really well with large dynamic data. So our next algorithm is join. So remember that join is one of the most time-consuming operation because you need to consider the total number of records in one relation and the other relation. We will present 3 algorithms for the join operation. The first one is the naive algorithm. This one requires 2 nested for loops. The outer loop is for the first relation, and then the inner loop is for the second relation. So we need to test whether the 2 records satisfy the join condition inside the 2 nested for loops. Yung mga nag-satisfy, of course, will be part of the output query. And then J2 is the single loop join, so it's also possible, but there is a requirement. It is required that one of the 2 relations ay merong access path or an access structure like an index or a hash key. So it uses a single loop, so meron tayong for loop for one relation. So we check for each possible record for that relation, and then inside that single loop we use the hash or the index to retrieve and check if the condition holds. For the third algorithm, it uses a 2-part process. First is sorting, and then the second is yung merge operation, which requires scanning the files concurrently by checking yung mga matching records. So we need to sort the records in both relations with respect to that attribute na necessary for the join condition. Second is we scan the files concurrently, matching the records that have the same values for attributes A and B. Okay. Next is the project operation. Actually, this one is a much more simpler operation in SQL. We just extract the necessary attributes, and then since the output of the project operation is just a set of distinct elements, so to eliminate the duplicate records, we just need to sort the output of the project, and then we can eliminate the duplicate values easier. Okay. For the set operations, yung Cartesian product, we know that this is very time consuming. As much as possible, we try to replace this with an equivalent operation. So as much as possible, iiwasan natin yung Cartesian product. But most of the time, yung reason why we do the Cartesian product is because we wanted to join the 2 tables, so might as well use the join operation. Ano pa? For the union, intersection, and set difference, ang ginagamit mostly is the sort merge technique. The 2 relations must be sorted with respect to the attributes that are necessary for joining, and then yung linear scan will differ depende kung ano yung need natin. If it's the union, then if the same records exist in both relation, only one is kept in the merged result. So if intersection naman, only records that appear on both relations are included in the merge result. So you can imagine how the set difference is applied and how the sort merge technique is modified for the set difference. Here are the cost components for query optimization. As much as possible, we wanted to have a query na mas mabilis mag-run. But there are other factors that we need to consider or other cost metrics that are also important. So, ito yung slide na to. The first one is access cost to a secondary storage. So, since medyo malaki yung data natin, hindi naman lahat yan magkakasya sa RAM. So, if we have, let's say, a computer and then we have a secondary storage na na hindi pa solid state, so medyo matagal yung I/O time if we wanted to access contents from the secondary storage na mas malaki yung capacity. So that's for a single computer. But sometimes we have a database server running on the cloud. So yung mga mas malalaking data natin are stored somewhere else. Access cost din yung data transfer from different locations. Okay, so another cost that we need to consider is the storage cost. So sometimes we need to store intermediate files that are necessary for the execution of the strategy. At the same time, yung computation cost din, the actual cost of performing in-memory operations, yung mga nabanggit natin na algorithms a while ago, it has a computation cost. Yung join natin is much more complicated in terms of computation compared to other computation like searching or projection. And then we also have memory usage costs. So this is the cost pertaining to the number of memory buffers. So remember in our pipeline evaluation, yung intermediary tuples na result ng mga operations natin are stored in buffers and then directed to the next operation. So we also need to consider those. And then lastly, communication costs, because if we wanted to query some data coming from a database server somewhere, so yung cost of transferring the data from the source of the query and dun sa panggagalingan or the database site, medyo matagal din. Okay? So, yung pag-aralan lang natin na compute is the computation cost. At ito yung mostly na-estimate. But for some computation, mas important din yung other factors like yung mga other costs in this slide, like storage costs and access costs. Okay, so next is some catalog information used in cost function. As my way of understanding this slide is what are the input parameters or parameters that are directly affecting the complexity of the query. The first one is the size of the data. So size of each file, because at the parang lowest level, data are stored in files naman talaga. And then the total number of records or tuples, and then the average record size. The second category is the access structures that you need to maintain to efficiently retrieve the data. So yung mga primary access methods, primary access attributes na ginagawa natin like indices or hash table. So it also has an effect on the cost of evaluating a query. So, yung paggamit ng mga secondary indices and number of levels of multi-level indices, just like in the B plus trees na gumagamit ng multi-level index. And then for item 3 and 4, the number of distinct values of a particular attribute, medyo mas complicated siya because if we have, let's say, konti lang yung distinct values ng particular attribute na yun, mas makakapag-generate tayo ng cluster index that we can use to efficiently access yung contents ng mas mabilis. And then, selectivity is the fraction of records satisfying the equality condition on the attribute. So, kapag mas marami yung tinatry nating i-retrieve and yung evaluation ng selection, mas matagal yung evaluation ng query.